everybody. Wish we were together, but this is the best we can do. So here we go. Let's start by finishing up our Christmas gift worksheet review, because the next time I see you in person, we will be having a quiz. The quiz will not have 16 problems on it. The worksheet has 16 problems. But all of the problems on the quiz will be like ones on this sheet. So make sure that you can do all of the problems on the Christmas gift worksheet. That will prepare you for the quiz we're going to have next time I see you. All right? The quiz will be partially calculator, partially no calculator, just like everything else we do. All right, here we go. We are ready for number 13. Now, pay attention to the directions. All we want to know is, are we positive or negative? That's all. We're not using our calculator. We're just figuring out, okay, if I were to find the sine of 100 degrees, would that be a positive number or a negative number? Okay, well that's easy. It all boils down to which quadrant am I in. So remember, if I draw 100 degrees, it would be like right here. So here's 100 degrees. If I were making a triangle, butterfly bow tie, this side would be positive, this side would be negative, and of course the hypotenuse is always positive. Remember, if I am left of the origin, I am negative, x is negative, y is positive. Sine is opposite over hypotenuse, or y over r. So in quadrant 2, the sine is positive. Sine is associated with y over r. So if y is positive, sine is positive. All right, tangent negative pi over 7. Now remember, in radians, my labels are these. Pi is 180, half a pi is 90, and so on. That is a negative angle though. So I am not going this way, I'm actually going this way. So I won't label that 3 pi over 2, I'll label it negative pi over 2. Go down, negative angle, negative pi over 2. Now this is negative 1/7 pi. This is negative 1/2 pi. Well, 1/2 is more than a 7th, so negative 1/7 is like right here. A 7th of a pi. This is a whole half of a pi. So I'm going to go ahead, I know it's in quadrant 4. Go ahead and make my triangle. In that quadrant, x is positive, y is negative, and of course r, or hypotenuse, is positive. I want the tangent. Tangent is opposite over adjacent. So opposite over adjacent will be negative. Tangent is y over x. In quadrant 4, x is positive, but y is negative. So when you put y over x, it will be a negative answer. Oh my goodness, cosine of 1,000. And that's degrees. So what do we know about 1,000? Well, it's big, really, really big. So let's shrink it down a little bit. If we go all the way around, we haven't really moved. So we have 1,000, but I went around, so I took out 360 of it. So now I'm down to 640. Well, shoot, that's still another revolution. So I'm going to go round again. That just brings me back to where I started, but I'm going to take out another 360. 280. So really, I went around, and I went around, and now I gotta go 280 degrees more. So 280 degrees would bring me just past 270. So I'm in quadrant 4 again. If an angle is bigger than 360, get rid of the extra revolutions, because they don't matter. You're just spinning. So in this case, I had 2 extra spins, so I got rid of 720, and that left me with 280, and 280 is right here. X is positive, Y is negative, R is of course positive. So I want cosine. Cosine is either adjacent over hypotenuse or x over r. Either way, the cosine of 1,000 is a positive number. Okay, next. Find the exact value of the cosine of 25 pi over 6. You will have a baby calculator to help you with this problem. So you absolutely could do 25 times 180 divided by 6. And that is going to be a big number. It's going to be like this one over here. We have that great big number, and you have to take out the extra revolutions. But I'd like you to think about something for a minute. You can do that, all right? You can do that. I am not going to, but you absolutely can do that. 25 times 180 divided by 6, shrink it down and go with that. I'm going to do this. I'm going to think about this as being 4 and 1/6 pi. Now think about that for a minute. 25 over 6. Isn't that 4 and a 6th? And I know that all the way around my circle, if I stay in radians, all the way around my circle is 2 pi. So if I'm going 4 pi, aren't I just going around twice? So really, can I just ignore that 4 pi? Because 2 pi is the same as 360, and you're going to ignore 360. 4 pi is the same as 2 360s, 720, so we're just going to get rid of both of those spins. So what I'm really doing is finding the cosine of pi over 6. Pi is 180, so this is the cosine of 30. All right, so here we go. 30 degrees is right here. Opposite, adjacent, hypotenuse. 30 degrees, 1, 2. So the cosine of 30 degrees, adjacent over hypotenuse, root 3 over 2. If you did it in degrees, you would be finding the cosine of 750. 25 times 180 divided by 6. What are you going to do with 750? Take out 720 because it's 2 spins. And what's that going to leave you with? 30 degrees. I don't care how you do it. It doesn't matter. Ultimately, you're finding the cosine of 30 degrees, which is 3 over 2. 9 pi over 7. We want a positive coterminal and a negative coterminal angle for 9 pi over 7. We haven't talked about this in a while. Who remembers? How do we find coterminal angles? To find coterminal angles, add or subtract revolutions. If I am in degrees, a revolution is 360. If I am in radians, a revolution is 2 pi. Since this is a radian measure, I am going to add 2 pi, here, so 9/7 pi plus 2 pi, and 9/7 pi minus 2 pi. Since I am in radians, I am going to add 2 pi, subtract 2 pi. Now, I know if you were here, somebody would be saying, oh, can we just change it into degrees? You can change it in degrees, add 360, subtract 360, but then you got to change it back to radians. Because if the problem is presented in radians, it must be answered in radians. So, I wouldn't advise that because it's a whole lot of work. A radian revolution is 2 pi. Add 2 pi, subtract 2 pi. So I'm going to get a common denominator, which is 7. So I'm going to add 14/7. 2 pi is 14/7. So 9 and 14 is going to make 23 pi over 4. And then I'm over 7. Over 7. And then I'm going to subtract. So 9/7 pi minus 14/7 pi will be negative 5/7 pi. So my negative coterminal I got by subtracting a revolution, and my positive coterminal I got by adding a revolution. Sometimes trig functions are undefined. Give an example. Well, if you think about it, the only way to be undefined is to have a 0 in the denominator. That's how we are undefined. I don't get zeros in triangles. I only get zeros from my circle. So I'm going to go ahead and draw my circle. Remember, I'm letting the radius be 1. So I can label those points. Radius is 1. And I need 0, and I need any angle. It just says, give an example. So I need some angle somewhere where something is undefined. So, I don't know, let's just pick a function, sine, all right? So we want this, sine will never be undefined, bad choice. How about tangent? So the reason sine will never be undefined is because it is defined as y over r. R will never be 0. R is 1. So sine and cosine will never be undefined. Tangent can be undefined because tangent is y over x. So we just need to find somewhere where x is 0 because tangent is y over x. If x is 0, you're undefined. So let's look around our circle. We need x to be 0 right there. So one way of being undefined is to take the tangent of 90. The tangent of 90 is y over x. That would be undefined. So that's an example. All right. Let's do a secant. We'll do a secant example. So what's secant? Secant is reciprocal of cosine. So it's r over x. Okay, so we need another angle. I'll do a different one where x is 0. Okay, so I know x is 0 here. So 90, secant 90 would be an example. How about down here? Is x 0 down here? So another example would be secant 270. Because secant is r over x. If x is 0, you're going to be undefined. There are infinitely many possible answers to this. To be undefined, just find some function, someplace that has a 0 in the bottom. Can't be sine or cosine. It can be anything else, any other function. it for that. Quiz next time. Problems on the quiz will be just like the ones that we have practiced the last few days, a little bit every day. Reviewing the basics of chapter 4. Now we're going to do a bit more graphing. Okay, so I'm in my notes now, section 4.4, problem 1I. And before I start, this is a cosine problem. I'm going to remind myself that a cosine starts at the top of the hill. So I got the part of the hill, then I have my whole valley, and then I have the other part of the hill. That's what my cosine is going to look like. Now I have to look at my problem, which is full of stuff, and one piece at a time, I need to figure out what's going on. So the first thing that I need to know is, where am I going to start drawing my picture? Like in a regular one, I start right here. Where am I going to start this one? Well, this tells me that I have been moved to the left pi over 6. So I'm going to label over here negative pi over 6. Okay? And that is where my cosine is going to start. My picture has been shifted to the left. Okay? So, left pi over 6. So I'm going to draw my hill, that's half my hill. I'm going to draw my valley, and I'm going to draw the other half of my hill. And I'm going to stop. When you draw your cosines, and I think they're the hardest ones to draw because of the way you've broken the picture, like half a hill, remember that wherever you started is where you are ending. So if you start at the top of the hill, you're going to keep drawing until you get back to the top of the hill, and then you're going to stop. The next thing I need to know is, how far have I gone? Because I need to find this hash, and this hash. I need to find those labels. And I'm not going to be able to find those unless I figure out how far I've gone. Okay? So, I know that the normal period, that is the length, horizontal length, of the curve is 2 pi. Once around the circle, sine and cosine have a period of 2 pi. Normally. This one has been divided by 2/3. Remember, this number right here divides the period. That's a divider. So I have 2 pi divided by 2/3, which is 2 pi times 3/2, which is 3 pi. So from here to here is 3 pi. That is not 3 pi. That would be 3 pi if I started at 0, but I didn't. I backed up. To find this number right here, you're going to take your starting point and add 3 pi. Now, fractions are involved. Suck it up, deal with it. Okay, we're big kids. You can do it. So this is negative 1/6 plus 3. If the pi's bother you, take them out. Just remember to put it back in. So that's negative 1/6 plus 18/6. 3 over 1, 18/6. That means I'm ending at 17 pi is the middle of the picture. So it is the midpoint of -1/6 and 17/6. Again, I'm leaving the pies out temporarily. I'll put them back in. -1 and 17 makes 16, and half of 16 is 8. So this is 8 pi over 6. Midpoint. Add them and divide by 2 or multiply by half. 8/6. I know that reduces, but I'm not going to ask you to reduce it because it is convenient to leave it with a common denominator, 6, because now I have to find this midpoint. So I'm going to have to add these, and it's easier for everyone if we just leave a common denominator. So you don't have to reduce that. You can if you want. -1/6 plus 8/6 is 7/6. So I add and divide by 2. So this is 7 pi over 12. So again, to find midpoint, add, and divide by 2, which is the same as multiplying by 1/2. When I had 16/6, it was easy. Divide by 2, 8/6. But when I have 7, I can't do that. So I don't divide by 2, I multiply by 1/2. It's the same thing. And now I'm going to repeat here. 8 and 17 makes 25. So 6. I need half of that, so this is 25/12. My amplitude is 2/3. Remember, this number multiplies your amplitude. This divides your period. So the normal amplitude is 1. So when I times by 2/3, I just get 2/3. So my amplitude is 2/3, and my period was 3 pi. Hang on a second. I am videoing. No, I don't need it anymore. Nope. I need bananas and that's all. Yes, fine. Okay. All right, sorry about that. This is Saturday morning making this video and all kinds of stuff going on. Anyway, that is our picture. That's it, right there. Okay, number 2. Oh my, this is backwards of what we have been doing. All right, so you have the picture. The picture is drawn for you and labeled, everything is fine. Your job is to write the equation of a sine and a cosine. Here's the situation, we talked about it before. These things actually continue on forever and ever. So depending on which piece of it you're looking at, you could think of it as a sine curve, and the way it is drawn originally, that's what I think of. I look at this, I see a hill, I see a valley, so I'm going to draw my sine curve. But if I look at it from a different point of view, a different starting spot, cosine curve. This is a cosine curve, right? So I can write an equation either way for the problem. And some of these blanks are going to be the same, and some of them are going to be different. So when I wrote my equation, I left room for 3 numbers. So look at the one we just did. I erased it. I should have left it up there. Look at the one we just did. See how there's a number out front? And that number controls the amplitude. So looking at this, I can tell already that the number out front is going to be 1/5. Whether it's a sine or a cosine doesn't matter. The height is 1/5. So that blank is going to be 1/5. That's my amplitude blank. Okay? Now, I can also tell if this is going to be a sine curve. This is blue. If this is going to be a sine curve, then this has to be x minus pi over 6. Why does it have to be x minus pi over 6? Well, I started drawing at positive pi over 6. So I shifted to the right. So x minus shifts you to the right. Previous problem we just did was x plus. It went to the left. This one goes to the right. Okay? Now, this number is the number that controls the period. All right? Now, I'm going to back up to the last problem we just did. The last problem we just did had a 2/3 right here. So to find the period, I took 2 pi and divided it by 2/3. This number divides the period. Okay, that's a divider number. So for a moment, I'm going to call that n. And I know that my period is 2 pi divided by n. I also know that my period is right here. One hill, one valley. So 1 pi over 6 to 5 pi over 6. That is 4 pi over 6. Period is start to finish. So I started at 1/6, I stopped at 5/6. That is a distance of 4/6. Okay? So I know that if I take 2 pi and divide it by this number, I'm going to get 4 pi over 6, the period. So let's cross multiply. 12 pi equals 4 pi n. Divide by 4 pi. And it looks like, and pi's canceled, it looks like this number is a 3. Divide by 4 pi. So that is the equation of my sine. Now, my cosine, we've already talked about, is still going to be 1/5. This is still going to be 3 because the period doesn't change. I can look whatever chunk I want, and beginning to end is going to be the same. Whether it's a sine or a cosine is irrelevant. The only thing that's going to change is, where do I start? If I want to look at this as a cosine, then I might want to start here. That would be a cosine, right? So I'm starting now at pi over 3. So this will be x minus pi over 3. When you write your equations, this is the only thing that's going to change. The curve is the curve. So its height and length are the same. You're just figuring out which chunk you're looking at. Are you looking at the blue chunk or are you looking at the red chunk? Now, some of you might be saying, wait a minute. Okay, I can do that, but what about this pink chunk? Yeah, what is that pink chunk? It's a negative sine curve. So you could write an equation for a negative sine curve. In fact, you can write infinitely many equations. Okay? I hate these problems because they're grading nightmares, because there are so many different possible answers. But they'll all have a 1/5, they'll all have a 3. And then you just decide where you want to start. So if I were doing pink, I would start at pi over 2. This would be x minus pi over 2. And of course that would have to be negative because the pink is a upside down, so it would be a negative. So that would be another possible equation. All right, let's try the next one. We're going to write 2 equations. For the picture. It's wrong. Let's see. Oh, all right, well, I'll set up my equations. All right, so what's my picture look like? It looks like my picture is starting at negative pi over 9. So when I just draw it like that, this feels like a cosine. So I'm going to start with the cosine, okay, because that's just what it feels like when I draw it. I know the amplitude is 6, so I'm going to put a 6 right there, okay? Now, I have shifted this cosine so it starts at negative pi over 9, which means this has to be x plus pi over 9 in order to shift it to the left. I'm doing my cosine curve. Now I got to figure out that number. I don't know what it is, but I know that my period is always 2 pi divided by that number. That number divides my period. So the normal period is 2 pi, but whatever this is divides that, so 2 pi divided by that. And that's going to equal my period. Now, my period is the distance from negative 1/9 to positive 15/9. Start to finish. So from negative 1/9 to positive 15/9 is how far? 16/9. So my period is 16/9. Start to finish is 16/9. So let's cross multiply. 16 pi n equals 18 pi. I'm solving for n, so I'm going to have to divide by 16 pi. Pi's are going to cancel. And that's going to reduce to 9/8. So this number right here is 9/8. Time. You simply need to remember that the period of a sine and cosine starts out as 2 pi, but it gets divided by that number. So 2 pi divided by that number is always going to give you your period. 2 pi divided by that number is always going to give you your period, which I can tell in the problem is 16/9. So there's my cosine equation. Now I need to figure out a sine equation, okay? So I need to find a chunk of the graph that is a sine. So in other words, a hill and a valley. So if I choose to start right here, and remember there are infinitely many answers, whatever you choose has to have a hill and a valley. So if I start here, I'm going to have my valley and then my hill. That would be a sine curve, okay? Remember, this number isn't changing and this number isn't changing because I didn't change the size of that picture. The amplitude is the amplitude, the period is the period. The only thing I changed is, where did I start? I started at positive pi over 3. So this is going to be x minus pi over 3. And I got to put a negative out here because the sine curve that I chose has a valley and then a hill, and that's upside down. So whatever is out here has to be a negative number. If you had chosen this part of the graph, the red part, then your equation would be positive 6 sine 9/8 x minus 11 pi over 9. There are tons of different possible answers. They will all have a 6 here and a 9/8 here. Then you just pick where you're starting to get the shape that you want. Okay. All right, one more. Here we go. Number 3A. What do you notice about this problem? We've been doing graphing, we've graphed some pretty tough equations, but what do you notice about this one? Yeah, this one has a +1 on the end. I know that this number right here multiplies my amplitude. I know that this number right here divides my period. I know this number right here tells me I'm going to start at negative pi over 6. Right, back up, pi over 6. What does that do? That moves the whole picture up 1. That moves your whole picture up 1. All right, let's pretend that's not there for a second. Let's do a little review here. Let's pretend that's not even there. Okay? So if that's not there, then I've got 2 and -2, right, on my x-axis, or my y-axis. Multiply my amplitude by 2. I have a starting point at negative pi over 6. The curve is going to be upside down, so it's going to come down and then up. And my period is 2 pi over 3. So from here to here is 2 pi over 3. My period is supposed to be 2 pi. But because there's a 3 there, I have to divide that, so my period is 2 pi over 3. Which is 4 pi over 6 if I make it over 6. And why am I making it over 6? Because in order to find my end point, I have to start at negative 1/6. This is negative 1/6 pi. And I have to add 4/6. So I'm going from negative 1 to 4. traveling for. So I'm going -1 plus 4, which puts me at 3. And again, you don't need to reduce that. You can if you want, but you don't need to. Now, what's going to be right in the middle? Well, I have -1/6 and 3/6. I need to be right in the middle of those two. So I'm going to add them and get 2/6. And then I'm going to divide by 2 or multiply by 1/2. Either way, I get 1/6. And a pi, of course. Now, what's in the middle of -1 and 1? Well, that would be 0, right? So right there, 0. What is right in the middle of 1 and 3? 1/6 and 3/6. That makes 4/6, and half of that would be 2/6. Beautiful. Absolutely beautiful. Now, I gotta move it all up 1. That's easy. Here is, a new reference line here. That's up 1. So this point is going to come up to here. This point coming up 1. I didn't do a very good job drawing it. It's actually going down to -2. So I'm going to go up 1, so it's going to be at -1. This one's going to be up here. This one is actually going to go up to 3. And then this one's going to be up to here. So I have exactly the same curve, exactly the same picture, but the whole thing has been moved up 1. Notice that does not change the amplitude. The amplitude of that curve is still 2. The height is still 2. Okay? Now, I need to answer all of these questions. All right, so the blue thing is my picture. That is the graph. Now I need to write down all of the pertinent information. So I need period, amplitude. Now those two I can already answer. I already know that. The period is, when I did it, I got 2 pi over 3. Reduce that back to 2 pi over 3. And the amplitude is 2. Okay, I already know that. This multiplies, so that gave me 2. This divides 2 pi, that gave me 2 pi over 3. Now, what is this PS thing? Well, that's my abbreviation for what we call phase shift. And another word for phase shift is horizontal shift. Well, you know that. What was the horizontal shift of our problem? We went left pi over 6. So you can either write negative pi over 6, or you can write left pi over 6. I don't care which way you write it. Negative means left. So it's perfectly okay to say negative pi over 6. It's where you start. Phase shift is where does your picture start? Where did you start drawing? VS, you might guess, stands for vertical shift. And that is +1. So you can either say 1 or you can say up 1. If you say a positive number, that automatically means up. But if you want to say up 1, that is absolutely fine. And then frequency. Frequency is the reciprocal of the period. So it is another characteristic of sines and cosines, periodic functions. And frequency is simply the reciprocal of the period. So if you have figured out, which you have, that the period is 2 pi over 3, then the frequency is automatically going to be 2 pi. Now make sure when you write that frequency that you're very clear on your fraction. 3 is in the numerator, 2 pi is in the denominator. In the original, in the period, 2 pi was on top, 3 was on the bottom. So on the reciprocal, it's going to be 3 over 2 pi. Okay? Don't write something like this because that's wrong. Very clearly make sure that pi is in the denominator. Okay, let me check my time here. Let me see if we have time for one more. Yep, we got time for one more. And then we'll stop before we get to the word problems. Or word problem, I guess. All right, this will be easy. We can get through this quickly. I need to answer all these questions again. But first I need to draw my picture. So here we go. This is a cosine. So I gotta remember what a cosine looks like. And this one has a bit of a problem. We have to make one little adjustment before we start graphing. You might notice that for the first time in all of our problems, this 3 is inside the parentheses. It can't be there, all right? It cannot be there. So, step 1, before I do anything else, I have to pull that 3 out. When you pull that 3 out, you're basically dividing it out. So this is going to be pi over 3. Before you start saying, well, wait a minute, stop. If you multiply 3 times pi over 3, don't you get pi? Yes. Factoring is division. Think about it. If you have 2x minus 6 and you pull out the 2, you get 3. How did you get 3? 6 divided by 2. So that's a pi. I'm pulling out a 3. I'm going to divide, get pi over 3. My equation now can be drawn. And I see that I am starting at pi over 3. I have an amplitude of 1/2. And I am positive. So let's start right here. There it is. We're at hill, valley, other half of the hill. I might as well fill some of this in. My amplitude's 1/2. What's my period going to be? Well, it should be 2 pi, but I've divided by 3. Was that the same as the last one? Yeah. Divided by 3. So my period is 2 pi over 3. Start to finish. By the way, that makes my frequency 3 over 2 pi. Easy points. Might as well finish this. What's the phase shift? Horizontal shift. I started right pi over 3 or positive pi over 3. And I haven't done this part yet, but I'm going to eventually drop the thing down to, so I'm gonna actually write down 2, which is -2. You can put -2, that's fine. I'm gonna do that in a minute, but first let's get these labels done. If the period is 2/3, that means I'm gonna start at 1/3 and add 2/3. To get this label right here, take your beginning point and add your period. So what is 1/3 and 2/3? Well, it is 3/3. I know that is pi. If you want to write it as pi, go ahead. I'm not going to make you, because because I know what's coming. The next thing I have to do is find that point right there, right in the middle. And how do I find the middle? I take 1/3 and 3/3 and add them and divide by 2. So right in the middle is 2/3. So we have 1/3, and our middle is 2/3, and our end is 3/3. Now I need this one and this one. Okay, well, 1/3 and 2/3 makes 3/3, and half of that would be 3/6. I know that's a half, write it as a half if you want. I'm trying to help you out here, lessen the arithmetic a little bit, so you don't have to reduce unless it bothers you to be unreduced. And then this one, I'm going to take 2/3 and 3/3, add them together and get 5/3. Then I got to take half of it, midpoint, so that's going to be 5/6. Now the only thing left to do is drop the whole thing down 2. Now be careful, this was a half. Okay, so this will be 1, this will be 1.5, I'd be negatives, and -2.5. Okay, drop the whole thing down 2. So I'm going to go ahead and draw my reference line down here at -2. All right, so I need to drop this point down, then this one, and this one, this one, and this one. So here is my cosine. 1/2 minus 2 would be -1.5, right? So it'd be a half above my reference line, just like this is half above here. This is half below my reference line, because this is half below the axis. So this pink thing is the answer to the question. And that is all of the information about the curve. All right, so we'll do this word problem next time, and we have a quiz. Next time I see you in person, we have a quiz over the Christmas gift worksheet. Have a great day. Stay warm.